Greetings everyone. I'm Patrick Gray. My background's in infrastructure, operations, automation, and a little bit of software development at NS1. Currently on the backend engineer on the platform team. A little bit about NS1. We run a managed DNS infrastructure, and we're an authoritative DNS provider where we run a global network. We also have dedicated DNS, which is NS1 provisioned servers that we run for you. We have a Pulsar product, which does active traffic steering based upon real user metrics. And then one of our latest products is that we have a whole enterprise DDI stack, which is DHCP, IPAM, IP address management, and then of course DNS. Some of our customers include Spotify, Salesforce, LinkedIn, Weather Company, and many more. For today's talk, I'm going to go through kind of a history of delivery at NS1, an interesting business problem that we had in the past few years, kind of a solution to that business problem and some ramifications, and how kind of the progress towards that solution introduced an even newer, like very horrible direct problem. Then I'm going to go through some like quick fixes to that problem around kind of delivery, and then also some longer term fixes, and then I want to go through what worked, some unexpected benefits, and then lastly, kind of the future of delivery at NS1. So traditionally, our infrastructure has been bare metal, and then even our cloud providers, we use Packet for a majority of our servers, so that's like a bare metal cloud. We don't use a ton of AWS or GCP or Azure, but we are kind of getting into that. And then we also have kind of colo locations that aren't quite cloudy, but they are pretty easy to use. We have a global network of co-located points of presence where we run our Anycasted DNS network that we've largely managed with Ansible, tons and tons of Ansible. All of our services that we run on this global network are containerized. There are some individual kind of like system level services that we run for like logging or metrics that aren't in containers, but mostly everything is running in containers. Historically, even though not all of these are, we don't always automate specific deployments, but we practice kind of canary rollouts and phase rollouts. For services that are a TCP endpoint, like our API, they're load balanced and they're highly available, so it's really easy to kind of artificially fail a health check, take a service out of the pool, and then kind of add a new one in, see what type of metrics, what type of logs are coming off of that. For DNS, because the network is anycasted, we can actually BGP down whole points of presence. No traffic is coming in from the internet there. We can do all sorts of things and then bring it back up, run a set of tests and then bring it back up. We also have certain types of like cron or job-based services in our infrastructure. They've historically run, like we've actually had like cron boxes that are like all the cron jobs run there. We're moving to a distributed scheduler. Specifically, we're using Nomad in order to make those more highly available. And we've kind of like mitigated risk there by having monitoring and alerting, letting us know like, oh, this cron job failed out in this horrible way. We run a staging and production environment, and staging is kind of traditionally, it's the same types of hosts, but just different numbers for cost reasons. And when I say it's production-like that, production-like down to the network layer. So it's the same exact switches, same hardware, same everything. So we can really, when we're doing testing or we're doing experiments, we have a very, very good reproducible environment, or it's the same as production. And then also what's interesting is that staging environment has an on-call rotation, just like our production environment. People who are operating the system, tech ops teams, and the SRE team, they can actually support developers when developers are going and trying to run either experiments or new deploys. So it's actually, we've had a pretty good culture of kind of like ops helping devs and devs helping ops And yeah, things have gone fairly well in the past. So that's kind of more about like our managed net, but we were presented with a business problem in the past 2 or 3 years, which was, customers are really enjoying using our managed platform. And so they actually like it so much, they say, oh, well, we would love to self-host it, run it on our own servers. We want to do multi-provider DNS, but actually use ourselves as a provider and use your software. And then lastly, people just want it to run on their internal networks and private networks and not expose their records and configurations to the world. So a lot of companies, I guess, have gone from selling on-prem software and then moving into the cloud, and they can kind of now insulate customers from specific upgrades or the operation of the software and create new kind of self-serve experiences in the cloud. But that requires a little bit of building and buying some infrastructure expertise. I think that's kind of an interesting problem to have, where you're trying to learn how to kind of keep a system up, whereas you might have been selling into customer environments, getting bug reports in the past. So we had an interesting problem where we actually had to do the opposite, and we had to learn how to kind of handle upgrade paths, certain things that maybe our operations team was taking care of for us. Like, we actually now had to go and solve old bugs and kind of build some of the operational duties into the software, whether it was like simplifying, writing more scripts, or actually building things into the application layer. And of course, we had to write tons more docs, because our operators are not going to be the ones who are actually deploying this thing anymore. They don't intimately know how it's put together. And that actually led to us simplifying how we deploy everything. And so the business solution, which I guess I already went into a little bit, was that, okay, we're going to build an on-prem version of the software, but we have to avoid handing customers like 30 plus containers. It's just not going to be an acceptable kind of deployment, or not an acceptable deliverable for our customers. So we come up with a new way to deliver our software. We say, okay, these services that kind of are part of the API, but they actually run separately in separate containers, we're going to couple them together. And then we actually built these kind of gigantic multi-process containers, which, if you're familiar with Docker, it's not really recommended to go multi-process containers, but actually there was already some there's already examples out there in the wild with a company called Fusion. They create something called base image Docker, which is actually, they add RUnit or run it, and then some other services that you can run inside containers in order to get into them remotely, or just have like certain programs still need syslog ports open. And so, if you need to run syslog in the container, then just to chuck it right back out to standard out, it's like, okay, if that needs to be there, that needs to be there. We saw some immediate benefits of trying to solve this business problem, which was that consolidation could actually help our managed product. Things had become kind of sprawling. The Ansible code base had gotten a little bit crazy. And so we're seeing we can actually simplify how we think about this for customers, but it actually would then pay it back, and it would actually simplify lives for our operations folks. And that by having the application team writing more tools that would help them. And then everybody loves simpler configurations and logs. The number of lines in our log stash config, I think, went from 50 down to 2, where it's just in JSON already, so we can just chuck it into Elasticsearch. So some time passes, and we build V1, and it's heavy, and it takes a while to start up, and that's fine for customers who are, it's like, oh, I spent 5 or 10 more minutes than I really wanted to get this thing set up, but it works. The software at the end of that is, it's the same performance software that we run on our managed net, but this is just not acceptable for local development. And so our developers are still running kind of like the many containerized version of Localdev with Docker Compose. And in the meantime, we build V2, which is still heavy, it's still a big system with a ton of services in it, but it starts up really fast. And it's better for customers, and then it actually becomes really, really nice for local development where you're only working on this one service out of the 20 or so that you want to stand up, and it's like, oh, like I can mount this thing in, and I have this new version of my software, and it plugs into this system that not only can I like remove the whole thing and just like take all the state away, but I can do it like really, really quickly, like a bunch of times in a matter of minutes. So, while all this is going on, we've got new environments. We've got a test environment where basically we're deploying master a bunch. We're just kind of like removing all the state, and then, oh, new version, bootstrap it. We've got a demo environment for customers that is accessible, and people can go in and see like new features. And that's more of like the stabler versions that have kind of passed through the test environments and really show kind of like, oh, this thing is now stable enough that we can say that like this will be sellable, or this will go out in the next release in a matter of like weeks. And then we've got a QA environment for what we call soak testing, which is basically long-term benchmarking. It helps us find kind of memory leaks or weird, any problem that's like requires the system to be up for longer than a matter of days. So these environments are actually really helpful, and they have specific, they have individual benefits that we get. Most of the bugs that we're finding are uptime related, or they're tuning issues. And then what's interesting is like, okay, so these are new environments right next to, like we've got our stage environment, we've got our production, but now we have these like even newer kind of like quick deploy environments, but we still have ops people who are ready to help. Developers are seeing this weird thing, like, oh, it seems like this process is leaking, but like, oh, actually, it's that service down the line that was down, and so it was like leaking memory because it was actually taking in requests, and then it was actually just spooling things in memory. But that other service down the line was actually like not accepting traffic. And so, we have like our kind of traditional relationship between ops and dev is still working here. But then we've got this new problem that pops up where, okay, so now V2 is fast enough, so most of our developers move on to using V2. It's like V2 is great, it starts up quickly, bootstrap's fine, but then everybody's individual development environments, it's like, oh, it's working on my machine, but it's not over here, and like networking is breaking, and like the startup, bootstrap, and cleanup scripts, they like work on Mac, but they don't on Linux, and then everybody's like mounting in things and mutating the containers a bit, and so it's actually kind of like not very, I guess it's kind of, it just becomes like this crazy process for getting your first version of Localdev, and people have varying levels of familiarity with Docker and Docker Compose, so they have different levels of ability to, when they get blocked on different things. And first it seems like, okay, these are isolated incidents and we can kind of solve each one as they pop up, or people, stand up and go and get some coffee and then they talk to somebody else about it, but then we start to realize like, no, everybody is hitting this multiple times a day. So basically, like, what does this mean? It's like danger, we can't deliver our new deployment model reliably to our own developers. Like clearly there's something wrong here. People are not happy about it. And what does this mean for new hires? Like, okay, we had this old system that everybody kind of understood and like made sense as far as like if you think about Docker. Okay, single process per container, so I see like 20 containers, 20 services. Now you see 6 containers, but it's like, I have no idea how many services are running. So what does this mean like for customers? Like, okay, like surely we're gonna hit bugs and degradations in customer environments. Like what's it gonna mean when a customer hits that? Like, and we're not there to debug it immediately with them. Clearly something is not great. So we implemented a quick fix, which I think was a little bit, people were super worried about this quick fix, but we decided like, oh, like what if we treat local development like its own environment, like just like test or QA or stage or production, and basically we created this channel, and we had somebody dedicated, like, okay, when people come up in there and they need help, like your job is to unblock them, get switched off of whatever you're working on and like help them. And so this actually was great because it routed all local development issues into a single place. And then not only were we unblocking people in order so that they could keep working, but we were actually filing bugs, and we got this new stream of really quick feedback into the reliability of the new kind of deployment and delivery model. So we created that feedback loop. We had fast response to bugs, and then an interesting thing was that so the integration tests, they would catch a ton of like really obvious bugs, but if there were like kind of either new services or new endpoints that were being exposed as people were building new features, they would go into master, and we would always have like a lag of tests. And so we would get early signals of breakage from people who were pulling new master, branching off of it, and it helped us kind of like get to that and solve those problems really, really quickly. So that was the quick fix. That was our like quick fix, and that worked for a while, and it kind of helped us pay down any types of bugs that had kind of like crept in. But over the longer term, all of the bug fixes that we were catching really, really early, those kind of like made the software mature and get better and get more stable. And it also we started to recognize certain patterns from developers where, okay, maybe we need new tooling, or maybe we need to mature some of the tooling and build new commands, new scripts for local operation. I think I ended up writing one command that was like basically, okay, leave the containers up, but like shoot all of the data systems down and like bring them down, and then remove all of their state, and then bring all the data systems back up, and you can basically reboot the thing without even having to like restart the containers themselves. And then even more lately, we've kind of been developing better documentation. New hires, when they come in, they get added to that channel, and anything that they have questions about, we encourage people to kind of like better our documentation as they hit certain questions, or as they're like learning the system themselves. And then lastly, over time, we've just simplified the configurations. Like, okay, these are giant containers. Like, we need single sources of truth for specific types of variables that need to be set for multiple services. And we're, I think it's on the next slide, or no. But yeah, so simpler configurations have really helped. So we do still have some unresolved issues though. We haven't like kind of perfected everything in this for Localdev. And also for customer environments, like every once in a while we get like a really weird, because we're delivering containers to customers, we've seen like really weird kernel configs or really weird networking configurations that have kind of caused everything to be unhealthy. But they're usually like super specific, and it's like, oh, we can figure out within, I guess like 30 minutes of seeing this issue, like, okay, so this is gonna require this one specific simple fix to all these containers, and then we'll publish a new release, or we'll get a customer a new version very, very quickly. The one thing that we still also haven't cracked is configuration changes that roll into these images. It's hard to kind of like exactly pin down like, okay, this specific configuration file, what type of ramifications is it going to have in Localdev. And some people, they're running the containers for longer periods of time, so they might actually be catching problems that we would regularly see in like a SOAK environment or a benchmarking environment. They might see those locally. We still can't protect Localdev from that. And the last thing is we've built up this integration testing suite over a while, so it's getting a little bit heavy, and it's still taking, sometimes a full test suite takes a long time to run. So we're working on getting that to fail faster if it detects any type of failure. In the future, what we've now done is we've basically said, okay, we came up with this, we had this business problem, we solved it, and now we're building these new containers for customers, and then we're actually going to take those same customer containers, and we're actually going to start running our managed net with those containers, and really kind of like dog food really well, and hopefully find any more bugs or any type of load issues early on. We are starting Canary Deploys instead of like more in a manual way like that we've always done. We're moving into using an orchestrator for that. We're doing that mostly with our API to start out, and then we're also looking into ways that we can do it with metrics for other services. And with Canary Deploys, we're also looking into, well, I guess as a part of Canary Deploys, we get automated rollbacks for bad versions. And then we're also looking into, well, not looking into it, we already implemented it in a specific way, but now we're looking to generalize more, moving certain parts of the configuration into the application layer and controlling configurations for services so that you get enough to bootstrap them and have them come up, and then they actually connect into some database for most of their configuration, and kind of like basically decrease the amount of text files that live inside the containers from the get-go. Thank you. That's everything.
What challenges are you facing? Because I know we all face challenges with this.
The challenges I think I'm facing is basically giving the developers similar tools that the pipelines run. In a lot of cases, some of these pipelines are secure, and giving that same feedback that they get locally is one of the challenges I face.
Yeah. Anyone want to share their challenges? That's definitely a hard one, especially like I feel like at Datadog we had that, right? Because we were working with a bunch of people that were essentially working on Datadog agent integrations, and we're like, how do you do things like security, right? So we had ended up working with SNCC, but then you have this weird thing of licensing, and you're like, wow, if I have like 1,000 open source contributors, like I can't really buy SNCC for all of them, right? And like, how do you replicate a lot of that?
Yeah, I think one of the problems that like I know a lot of my customers face is like with all these like software as a service like Azure, Google Cloud Compute, AWS, like especially with containers, like they're running against a lot of things that they don't necessarily own, like load balancers or databases or queues, and it's like how do we replicate that locally? And like I think people end up creating like these network topologies like between all of their microservices, maybe in like some sort of private cloud. Like how do you replicate that? And I think that's like somewhere between a tooling question and like I don't know. It seems like a kind of tough question that we're also facing.
Yeah.
Yeah, one of the challenges my users are facing is the speed at which they can spin up their local dev environment. We're mostly a Microsoft software and trying to get into Kubernetes, so spinning up a local, and it has to be on-premise, so spinning up a local Kubernetes cluster on Windows with the ingress controller and certificates and everything takes like days for a local dev.
Any other challenges that folks want to share before we move on? And maybe some folks have had successes. What successes have you had? I mean, we all have these challenges, we all make workarounds, but even if it seems like a hack, if it works for you, it might work for someone else.
So we don't actually have the success as much as we do anymore, but about 2 years ago, we ran everything in EC2 still, and so we actually got like a good Docker Compose file that kind of covered almost everything, running them all as containers. But to move from that, as we moved into Kubernetes, we have some things in EC2 and some things that are actually containerized, and so we have not found a good way to bridge this gap of time. So we're going to be there for a while, I think, in a very hellscape land.
I've seen a lot of success, back up a little bit, with, thanks Jason, leveraging Ansible for configuring your local environment, like even just your local laptop. Like you start into a company, and a lot of people like manage their dot files in GitHub and everything. Actually, this was a trick I borrowed from Datadog, where you have Ansible set up all your local config, install all of your applications, get all this pre-configured, and it can help accelerate and standardize how your environment is configured.
Nice. That's a good tip. Actually, Ansible, especially Ansible, like so Arlington and I both used to work at Datadog. Yeah, for a while it was like chef stuff, and like the setup for Localdev was, oh my God, it took forever.
You can put the mic in my face. So, the one thing that I've done, which was a great success, is that I actually have local development is containerized, and so that it's just mounting your home directory into the container and running all the tools. That same container is running on Jenkins. So when any change happens, they would just say, exit the container and start it again, and then you'll have the most up-to-date thing, and it's the same thing that's running in Jenkins. So there should be no excuse of why is it working on Jenkins versus not in my local development? Yeah, it's my machine, or it works here, or it passed on my machine. No, it didn't.
And I'm assuming then that like what's in Jenkins is also essentially what's in prod.
No, for the test environment.
Oh, for testing. Gotcha.
It's for the test tools.
Gotcha. Okay.
For successes, I want to echo the communications that the speaker had of. We're also doing something similar on Microsoft Teams, where we funnel all questions into a Teams team with specific channels for what they are looking for. So people can refer to that channel, ask questions, and go back and see if anyone has asked that question before. So that works very well internally.
Cool. Yeah, communications is a struggle. Also, documentation. Have folks had any successes around that, other than like every time someone new onboards and has like a horrible experience, they write down notes? No, there's a lot of like nods of like, yeah, we do that.
Again, to borrow another thing from Datadog, we actually had an internal enablement team that was responsible for helping document this type of stuff and train up our support engineers, and allowed for, it was the single best onboarding experience I ever had was going to Datadog, because they had to go through these problems and were very focused on, infrastructure as code, documentation as code, and repeatability. They're very diverse, very spread out across the world, so it was key and important that everyone was up to speed and up to date, and found that really helpful.
Cool. So we do have one more. As I'm losing
I will get one more success in there. In the prior iteration of this, we use Inspec to test production, and I actually wrote Inspec Suite to test the configuration on local devs, the configuration that was needed. So then the tests were they would just execute the test and say, that was the big thing, is like something usually was they misconfigured something or they didn't do it right. And so having an automated test to say that your configuration is wrong on the local dev.
So one thing that we've added lately is we actually have most of our stuff's written in Go, and so with Go Vet and Go Lint, we've kind of been adding in more documentation. And anytime you touch a file, you're kind of responsible for like going through, and like we have some stuff that's not even commented according to like Go Lint, and so now we're like adding in all the comments for all the software. And then we recently started like an epic of every single service has to have a README, and we're kind of like backfilling like that way.
Nice. Cool. So, giving you all magic wands, what do you want to see in 2 to 5 years? What are the things that should be solved by then?
I think an interesting development is the concept of no state on your local machine. So thinking about Chromebooks, right, and iterating in the cloud, iterating in systems that. So for example, if you get a Chromebook, plug into a Google Cloud account, you can do everything, right? You get a Cloud Shell in there where you can do some operations if you need to. You get full API access. You have your own little project where you can hook into all the CI/CD components, all the load balancers and Kubernetes and whatever else you need, and even at a low cost, sometimes even free, depending on your tiering. I think that moving towards that model will help. It helps get rid of some of those "it works on my machine" problems. It also allows you portability, right? You can be remote, you can be anywhere in the world, and not have to worry about, did I break my laptop? Am I traveling to a foreign country that doesn't allow certain data export privacy stuff, or it might be compromised, so you just wipe your machine and move on, type of thing.
I'll say something. I met with my financial advisor a few weeks ago and actually had a Chromebook, and everything was running in Azure. But the whole thing that this was a push wide was that if one of the advisors' laptop was stolen, there was no data on it. Everything was in the cloud, so they really saw that as a protection mechanism. And then they didn't have to refresh people because they could just spin up the resourcing on the instances in the cloud if they wanted things faster or whatnot. And I thought that was really forward thinking about from the data privacy and any of the sort of like information leaks, that it was an interesting way of approaching it.
I think that's sort of an interesting idea too, because so I was talking with Sean Sullivan, who's one of the other speakers at the conference, and he was saying he had to explain what GitHub was to a non-technical person, and the easiest way that he boiled it down, he was like, it's sort of like Google Docs for like code and things, and I was like, that's a pretty good analogy. Like, it gives you a place to collaborate and share. But then you realize, no, I have to like git clone things, and so it's like it's still more like passing around Word doc files and editing them and then like pushing them up somewhere. But I think that is an interesting idea, right? We've had documents that we like used to email around attachments and crap like that, and like now we just do it in the cloud. And so I think to your point, Arlington, like eventually I think the magic wand is like we're gonna start moving everything, including our dev environments, up to the cloud. Any other successes or anything that people want to share, challenges, successes, or magic wand stuff before we close out?
One thing I also want to expand that a little. What don't you want to see in 2 to 5 years? Those things like, I really hate doing this. I never want to do it again.
My current company has a very monolithic, quote-unquote, legacy stack that the irony is it's actually containerized for your dev environment, but it's not for prod yet. And it's like a 32 gigs of memory requirement just to run this thing. Like, I want to see bad stuff like that go away, right? And monstrous container files and all that.
Cool. Well, that brings the discussions to a close. Thank you all for participating. Thanks all for coming.